Welcome everyone. Today we have our another new episode. This is our 458 episodes. We have our world famous speaker, Professor Edward, Professor Donald, Professor David Smith, and Professor Rob. Already they are very famous with our World Talent Economy Forum, and they contribute a lot for World Talent Economy Forum. Today we will discuss about sustainable and modern energy. Yes, we have a lot of debate and lot of argument, but definitely we will bring some interesting solutions. Professor Edward, what you want to add?
Well, yes, thank you for this interesting discussion because energy really is very important. But I want to start by saying I think the issue first and foremost is not sustainable. When you look at an energy source, you have to ask, is it cheap and is it reliable? Those are the first two things. Remember, energy is literally the blood of a modern economy and a modern civilization. You can go back and talk about our early ancestors discovering fire as a source of energy, and then you can go from there. So energy is really that important. But what's important is how cheap it is and how reliable it is, because if the more energy costs go up, the more we can't produce as much, prices go up, and or at least pushed up. And so those are the first two things you have to ask about. Then the next question comes about to sustainable, and here there really are two issues involved. Sustainable in the sense that, does the energy source have serious harm to human beings, measurable harm to human beings? Pollution, of course, is the obvious example of that. If you go to Los Angeles, it's in a big basin, and for decades, the pollution from the automobiles just hung over the city. If you take a look at London, up until the 1950s, you look at what coal was doing because it wasn't filtered properly. Again, you see these smogs that were really damaging human health. Those are very important issues. The one that I would urge your audience to be cautious about and look beyond the narrative is whether sustainable has to be low carbon in order to deal with the concern of global warming. Now, in that context, the two best energy sources right now, if you take both cost, reliability, and environment into account, are nuclear and natural gas. Nuclear is very efficient. It also doesn't put out any carbon. So if you're really concerned about that matter, nuclear is a very, very sustainable source of energy. The problem is that there's a lot of prejudice against it. Of course, everyone knows about Chernobyl, but that was because the technology was very, very bad. 3 Mile Island was the big disaster in this country, though nobody really was killed. Fukushima they built it in the wrong place, and there were a lot of problems there. But if you look at nuclear over decades, going back to the 50s, it's been a fairly cheap, reliable source of energy. By the way, I want to note just something real quick about natural gas. It's interesting. In 2001, the United States put out 5.93 gigatons of carbon dioxide from burning all the various fossil fuels. Today, it's only about 5. So it went from almost 6 down to 5, mainly because of the introduction of cheap natural gas from fracking. So again, if you're concerned about carbon dioxide, here's something that brought energy costs down in the United States and, of course, had a good impact if you're concerned about carbon. Right now, the technologies that are not very good by any of these measures are wind and solar. In the United States, wind provides about 7.5% of our electricity generation, solar about 1.5%. But there's serious problems that we face now with these renewables, is what they're usually called. First of all, is storage, reliability. Batteries are very important because a lot of times the sun isn't shining and the wind isn't blowing. And so you need batteries to store the energy. And right now that is a very serious problem. And especially when you're doing it on an industrial scale. It's one thing if you have solar panels on your roof and you have a Tesla battery, well, you're probably in pretty good shape. I can't afford it right now. I wish I can. I won't work on that. So thank you for Elon Musk for pioneering this. But when you're doing it on a massive scale, I've looked at some of California's numbers, for example, and how much backup they have if their system goes down. It's not very much because they just don't have the batteries to store. The next point about those renewables is they are very polluting. The inputs, And I'm thinking especially about mining for rare earth elements, cobalt and lithium that goes into the batteries as well as turbines and so forth. And they're producing very serious environmental problems in China and Mongolia, especially cobalt mining in Congo. All of the human rights groups have denounced the use of child labor, for example, to mine cobalt and lithium in South America. So you have these environmental problems just getting the inputs into the renewables. But what's interesting is that in the United States, we do have, for example, our own deposits of some of these things that we could mine and do it much safer because we have a lot of safety standards in this country that are very good. But unfortunately, because of what I call almost a superstition, we've driven out those ability to mine. The other things, and I'll go down very quickly here, my final points, because I have to get off in a couple of minutes. Wind turbines, the best place to put these big wind turbines is offshore because there tends to be breezes all the time, and the wind is blowing. We only have one in the United States, and it's offshore of sort of Rhode Island, Massachusetts, that area. And the reason is because for decades, environmentalists have opposed wind turbines offshore because of the environmental damage that they contend that the wind turbines would be doing. And also, by the way, for various places in the United States for wind turbines. So that's a problem as well as looking at something that's renewable but actually can harm the environment. The other problem I'll just mention is, for example, I did a calculation. If we got rid of all nuclear energy and fossil fuels in the United States, which is one of the policies that's being advocated by some in this country, how would we generate the approximate 8 billion megawatt hours, that we need for energy? If you use the solar approach to generate that electricity, and I'm using here the Nellis Air Force Base facility, which is a very cutting edge solar facility, you'd have to cover an area of New York State and Vermont with solar panels. If you use just wind turbines alone, instead of nuclear and fossil fuels in this country, you'd have to cover an area of Arizona, Nevada, California, Oregon, and part of Washington State. I'm using the model of a facility in Indiana right now, meaning you have very, very serious problems. The other big problem, by the way, is disposal. There's a big problem in this country disposing the wind turbines because you can't recycle major parts of these huge wind turbines like you can other products. So I want to say two final things here. What's interesting is that the Europeans and the Germans have tried to they want to get rid of all of their nuclear and their fossil fuels. Problem is they're now relying on fossil fuel energy generated by Russia, which of course gives Russia a hold over Germany. So when Russia ends up invading the other part of Ukraine and the Europeans protest, the Russians are basically going to say, hey, too bad. You want us to turn off the spigot? So, I mean, look, sorry, guys, that's the reality. What's interesting is just in the last week, the Europeans are considering saying that nuclear and natural gas are now acceptable, which would be a very, very smart move. France, I think, still generates, half of their energy by nuclear. And I don't think the French are going to get rid of that because it's a very efficient source. So I want to say one final thing to those of you who are listening, your listeners, who are the main audience. It's very important for entrepreneurs to look at how you can develop, for example, better batteries, how you can develop better technology to generate energy that is cheap and that is reliable. I saw one facility that I was really excited about, but it turned out not to be very efficient. And it was the Crescent Dunes facility in Nevada. I was flying in a plane, this is in 2016, over Nevada, and I saw this incredible thing. And what it turns out to be was it was all these mirrors in the desert, which of course is very hot in Nevada, and they were focusing the sunlight onto a big tower and storing the energy in the tower. I think it was with salt. And then the idea is that when it cools down in the night, they've got all this energy they can generate. And the Nevada Energy folks were really excited. They put hundreds of millions of dollars into it. And I thought, wow, this is really cool. Unfortunately, they had to shut that down. It just was very inefficient. It was cost inefficient and energy generating inefficient. So the point is, to your entrepreneurs, your talent who's listening, do look at these things, but get beyond the narrative that you hear about a lot of these technologies. Look at the real issues involved. Look at the real problems that so-called renewables generate, and then try to come up with something really cool and really creative to find the energy source of the future. Because right now we're pretty good on nuclear and natural gas, but in the future, we'll probably need some other things. So folks, go for it. Find some good renewables, but renewables that are really sustainable and that really are cheap and reliable, so that when you have a hurricane, you don't, all the electricity goes out, so you can't charge anything anyway. And how do you think you charge electric cars right now? You charge electric cars by plugging it into something that goes to a factory that's probably run by either nuclear or natural gas or coal. Okay, so guys, get realistic about this. So thank you very much. My colleagues might have a few dissenting opinions. I don't know. I'll have to watch this when I get back from my errand. So thank you very much.
Yeah, thank you. Thank you, Professor Edwards. We have debate this Friday. I want to invite you because we have our world-class debaters. They naturally attend. So maybe if you join in the debate, it will be more alive. So Professor Donalds, I know you have some interesting point you want to add. Can you unmute, please?
Well, I think it's a little hard to discuss things when people kind of make up statistics. Let me just talk a little bit about California, which is 14% of the population of the United States, and it's by far the biggest GDP. We also provide about 14% of the gross domestic product of the United States, where there's whole state, you can add together a dozen states and they're not as much, they don't contribute as much to the economy as the United States, as California. And in California, our power mix is, we're still using a little coal, and for nuclear is 9.33%, and hydro, which is sustainable, at least as long as we still have water, is 12%, and wind is actually 11%, and solar is 13%. So altogether, renewables are about 33% of our mix. And then if you add hydro into that, it becomes about 50%. So half of our power, in fact, geothermal is another 4.89, another approximately 5%. So 55%, the majority of our power is from renewable energy already. And somehow we muddle by. And I think that when you're thinking of storage, you have to realize that peak demand is during the day. So what you can do is you can start striking a balance. And one of the things that happened is that coal got more expensive than natural gas. And natural gas is less polluting than coal in a lot of ways. I mean, it doesn't have icky, carbon, stuff that you have to breathe. And the other thing about natural gas that's important to understand is if you have a natural gas power generation, you can turn it on and off in a very short period of time. Whereas coal-fired plants, you pretty much have to keep going all the time because it takes a long time for them to heat up. And natural gas will heat up just, almost instantly, but it takes time to make the water hot and stuff, but it's very quick. And so you have to start thinking, instead of thinking in a black and white way, where you're saying, well, everything is, everything's renewable and renewables aren't reliable, and so therefore we should not think about renewables. I think a different way of looking at it is you ask yourself, what percentage of the current energy mix can we substitute for renewables? So if we're using 50% as much natural gas as we would be if we weren't using renewables, then all of a sudden that's a 50% reduction in bad carbon dioxide. So, and then over time, we can, inch our way into using less and less natural gas. And coal, we use practically no petroleum in California. It's a fraction of a percent. And so it's possible to do because we're doing it. And countries all over the world are increasing their mix of renewables. And interestingly enough, when you think about it, electric cars are batteries that store electricity. So if you can charge your electric car during the day when the sun's up, you're storing power, which you can use later. And it's just solar power. One of the things that I think is important to understand is I believe we need to go, and we are going to, an all-electric economy because you can, as we just start using different things, and I want to, maybe not in this thing, but I want to talk about some of the different ways that you can generate power. There's quite a few. We're talking about solar and wind, but there's all kinds of ways you can do it with waves. You can store power by all kinds of mechanical means, and I'll talk about that later. But what I want to point out is that if you start using renewables during the peak times, you're going to be cutting down the amount of natural gas that you use significantly. And I think that's a goal that you need to start. However, when we have an all-electric economy, the United States, which is now addressing this thanks to our new president, has a pretty poor electrical grid. It's pretty old, and a lot of it is unidirectional. Like it'll send electricity out, but it doesn't get very much information back to control the electricity. And in theory, a robust electrical grid, if it was sunny in Fresno, would be able to start putting power onto the grid that could be used elsewhere, like Santa Cruz or San Francisco, where it's foggy. And I think that the better we make that grid, the smarter we can use AI, the smarter that we can get about putting the power into the places where it's used and not wasting it. And I think that that's another thing that we can do that's something we're working towards in the future. And if some country is just developing their electric infrastructure, that's something that they really need to think of from the beginning. And I'll pass the baton. Thank you all.
Thank you, Professor David Smith. Like, what you want to add, especially sustainabilities and for energy development.
Well, Sharif, thank you. You always choose topics which have a variety of opinions, and as we put them in place, coming from a state that is one of the energy producers, you tend to look at this slightly different, and I appreciate what Donald and Edward has said there. What I begin to see is, as Edward talked about, one of the other renewable energies that is very green is actually looking at hydroelectric power. And what's fascinating to me is that some of the new science and some of the new mechanical engineering has made hydroelectric power a lot more accessible, particularly as you look at the growing trend of point of use generation for power and microgrids. I personally think as we look at green power going forward, you're going to see an explosive growth of microgrids as opposed to the large grid structures we have today, which are actually fairly inefficient in transmitting electricity at distance. And you're going to begin to see those. Nuclear power, as Edward was talking about, has had a very interesting road with plants being decommissioned, coming on. But as you look at the cost of energy, nuclear is still one that has a fairly low cost of the actual power to produce. a fairly large impact of its sustainability, but the political roads around it are the difficult ones for nuclear to travel today. Uh, Wind power, solar power. I can tell you, as someone who survived the really 100-year winter storm we had in Texas last year, uh, solar power and wind power was a 100% failure in the state. We're a warm state, was not prepared for weeks of uh, in the single digit temperature, and our wind power stopped producing. Our solar power quit producing, so it fell out of the energy group. Now, during the summer, great green power source here in Texas, but it doesn't handle all the way around. One of the trends I love seeing growing is the bioenergy, particularly as we look at the side benefits we have with bioenergy and its different forms. Fantastic use of it because it's a hybrid use, because it helps us not just generate power, but generate other elements we can use as well. My favorite is some of them, which is taking agricultural waste, both plant waste and animal waste, and using that to generate energy from. Oh, and then that also turns into fertilizer. Oh, that also turns into feedstock and other elements like that. So you get these multiple uses out of it. One that I see taking off a lot, and it's one that I'm tracking quite a bit right now, is geothermal. Uh, Places in Europe, other places have used geothermal power for a long time. There's a lot of it around. Our infrastructure is just not in place to tap it well. But once again, as we begin to look more at going to microgrids and things, I think you're going to see a growing use of geothermal as you begin to go forward. But just to put it in kind of a context, uh, the green energy, sustainable energy market size in the United States was about $10 billion in 2020. And we really see it growing about 20% a year going forward. In 2028, it's projected to be right at $41.6 billion directly attributed to the green energy impact. Now, COVID did slow down its growth in the United States, and we can begin to see this. But one of the enabling factors we see in the whole green energy and sustainable energy is the really the digital transformation of the energy management systems, and that is reshaping our whole energy system as we begin to apply more digitalization to it, more Internet of Things sensors. We're even seeing in energy management, particularly in sustainable energy management, the utilization of digital twin models to begin to look at how you can vary the mix of these different power sources for maximum output, maximum savings, and maximal impact in being green on the environment. So a lot of changes, a very dynamic area, which you always choose very dynamic areas for us to look at. But a lot going on, and it's a complex mix of looking across the entire ecosystem.
Thank you, Professor David Smith. Professor Rob, I think there are some questions from audience. You can respond to this question as well as you can add your points. Professor Rob.
Sure. Let me go to the questions. A couple clarifications. We tend to mix up energy sources and how they're created and use them in the same conversation. Generally, the energy that we use, the power sources that we have are electrical, fossil fuels, and coal, which is kind of a fossil fuel, and natural gas. The way electricity is generated is air, wind. I said air, wind, solar, geothermal, nuclear, and hydroelectric. So the of the electrical generation capabilities, the ones that are cleanest are typically hydroelectric, wind, solar, and nuclear. The problem with nuclear, and it was discussed earlier with regard to the EU, is that France really likes nuclear and is increasing their nuclear footprint. Germany really dislikes nuclear and is decreasing their nuclear footprint. But this really has to do, I think, a lot with the perceptions of the technology in country. However, there is a problem with nuclear fuel disposal. Nobody wants it. It's not a lot of material, but it has become a problem both in the United States and Europe in terms of areas not wanting the nuclear fuel disposed of in their area. Traditionally, oil and gas has been the bigger environmental problem. We've got issues with regard to transport, issues with regard to use, issues with regard to how it's mined. Coal is also relatively dirty. It's clearly in sharp decline at the moment as a fuel source. Also relatively dirty to use and relatively dangerous to mine. With long-term impacts on miners' lungs and overall health. The biggest barriers to sustainability in a green economy development really are two things. One is the existing infrastructure and economic model of oil and gas carries an awful lot of weight. It employs a lot of people. It generates a lot of money. And oil and gas companies traditionally are very aggressive in terms of their lobbying efforts and political funding efforts, which makes it very hard to extract, to remove yourself from those sources. They kind of embed themselves in government and in a way corrupt that government, make it very hard for the government to move away from that source, which has been problematic. This was a problem that was identified way back in the 1920s and 1930s. But even at that time, the petrochemical industry was relatively strong and was able to cause a lot of those reports to disappear or to not get the airtime that they otherwise would have received. Otherwise, we might have gone a different way with regard to our energy development. The big issue with regard to electricity is transport. You lose a lot on transport. A number of our speakers have talked about California. California loses about 10% of its electricity that's generated over transport, and so going back to what David Smith said with regard to microgrids and moving generation closer to the users, that has an inherent advantage in terms of eliminating a lot of that transport waste. It's interesting to note that with regard to transport long distances, the summer when you need the electricity the most, that's when you tend to lose the most during transport because heat causes the wires to stretch. And as the wires stretch, they become less efficient in terms of carrying the energy, and your losses go up. In the winter, they contract, but in the winter, we often use things like natural gas to heat our homes and factories and the rest. And of course, that's a different transport issue. You can have some significant problems with transport in terms of natural gas, in that the infrastructure pretty much worldwide to transport natural gas is aging. And when you get a breach or an overpressure situation, it can have bomb-like repercussions. We've had relatively large explosions here in the U.S. when natural gas fails. For whatever reason, we don't cover it broadly, but you can lose up to a neighborhood when one of these things goes, and largely due to the fact that the pipes are aging or haven't been properly monitored or checked for leakage. What pro-ecological activities are carried out in the region where we live? I guess you'd have to check with your regional government, because I don't know where you live. But globally, the kinds of things that are going to place, of course, is co-funding of solar and wind. As other speakers have pointed out, wind and solar have significant problems with regard to generation time. The wind tends to generate the best mid to late afternoon into the early evening. Solar only when the light's out, and generally when the sun is overhead. So between 10 and 3 in the summers when you're going to get the most generation. I've got a solar plant on my own house. And in the winter, it drops off quite a bit, both due to clouds and due to the indirect nature of the sun, unless you have panels that are solar tracking. But even with tracking panels, the solar energy is traveling through more of the atmosphere, and so you lose an awful lot of power generating capacity in the winter. So it's nice that we have alternatives in terms of heat. A major issue right now is a lot of areas are trying to aggressively go to electric power, which can be problematic because in most areas the plants that cover peak generation are relatively dirty coal and oil-fired plants. The older plants are brought up online to cover peak levels, and the more people we get on the electrical grid without building up our nuclear, geothermal, solar, or wind capability, the bigger problem you have. One of the things that's exacerbating the power problem right now is electric cars. Used to be at night. The plants could shut down and do maintenance. Right now, as more electric cars come on grid, that's when people are charging their cars is at night. And that's causing us to go into a higher energy usage model, which forces those plants to stay online, and then you get more breakage. The plants then catastrophically fail because they can't be brought down to do the maintenance during a normal nighttime cycle, which is a significant issue. And also with regard to grid coverage in larger countries like here in the US, when you have a power shortage, other parts of the nation are supposed to step in and cover that power shortage. But if they don't have excess capacity, or if they're losing an excess amount of power over transport, that's very ineffective. We had a catastrophic failure in Texas. Texas doesn't participate in the nationwide grid. They stand alone, and they were not able to get backup power. It's been mentioned that both solar and wind failed during that time, but the wind failed because the turbines hadn't been hardened against weather. They had installed turbines that were not designed to work in cold weather, and so the cold weather caused them to cease functioning. And of course, solar, when you've got overcast and very cold temperatures, the solar panels get covered with snow and ice and don't generate it. Of course, the sun, as I mentioned, is lower on the horizon and isn't as effective. Plus, you get a lot of clouds, and solar drops off rather dramatically. There've been some interesting experiments with regard to doing extraterrestrial solar generation, which would then function 24/7. But beaming the power to Earth has been proven to be at much too high a power loss problem. Plus, you've got relatively high safety issues with regard to people coming into the line or animals coming into line with that broadcast power. So broadcast power, at least for now, hasn't proven to be viable either from a health standpoint or from an efficiency standpoint. And geothermal really is kind of one of the things that showed to be the most promising, but it is wicked expensive to put in and is not generally as reliable as you would want in areas where you've got earth movement. High earthquake issues can make geothermal plants less reliable than they otherwise might be. And sadly, in a lot of areas where you might want to put in geothermal, they are relatively active, and that brings into question the geothermal issues. And then you've got other concerns. For instance, if you do penetrate the mantle with the geothermal plant, there are concerns that could create other issues with regard to the power source that could be very dangerous. And there are concerns that it could destabilize a geography. I think those concerns have largely been disproven at this point, but it's one of those things like we had with the Great Hadron Collider, where they did the analysis and determined that the chance of creating a black hole on the Earth was relatively slight, only to find out they were magnitudes off in the wrong direction in the analysis. We're still here, so it didn't kill us, but it's always concerning when you're bringing up a technology that sometimes the analysis isn't as consistent or as accurate as you would like. See, one final thing. What is the affordable, reliable, sustainable? What is affordable, reliable, sustainable, modern energy? Well, a lot of things are affordable if you get to scale. Hydrogen in particular looks really good if you get to scale, but putting in place distribution and fueling is proven costly and problematic. Even though you could use much of the same infrastructure that you use for gas, though you would have to drop different tanks and pumps. The stations are in place and would arguably be easier to put in than electricity in some cases where your generating capacity is low. If you look at, for instance, phase 3 electric chargers for autonomous cars, those are really expensive to put in because they require a tremendous amount of power, and you have to put in place some type of storage capacity. One final comment with regard to electricity: the weak link with electricity is storage. We went through a period of decades where we did not do a lot of R&D with regard to electrical storage, and we're paying for that now, which is why we're kind of locked into lithium ion, a very unsafe and relatively unreliable storage medium. Personal experience with lithium ion, one of the people almost lost their house to a lithium ion fire, and so I came up to speed rather rapidly on the technology. We've got other things in the pipeline, lithium compounds like lithium air, but they haven't yet proven reliable at scale. The expectation is by 2030 we will have an alternative source of energy storage that's better and cleaner, and we can recycle much more effectively than lithium ion. But we've got a number of years to get there and then get the manufacturing capacity up and bring our understanding to the point where we can use this stuff safely. I do recognize that energy storage in and of itself can be a problem. Lithium ion has an energy density that's currently about 1/3 the energy density of dynamite, which showcases that when it goes up, that rapid release of energy can be very catastrophic. And a lot of us are kind of surprised, at least in the cover batteries, that we haven't brought down a plane catastrophically as a result of this. So we've had some really close calls with the lithium ion storage cells on the 787. Where the planes have had to be brought down relatively quickly. To my recollection, nobody's died yet because of that, but it was only a matter of time, and it did require those battery installations to be redesigned much more safely. So it's an area of a lot of change. The big problem to solve is energy storage. If we really want to make wind and solar work as effectively as we would like and convert over to that kind of an energy model. And hydrogen remains one of the most powerfully positive alternative energy sources out there. It just doesn't seem to be going anywhere quickly. So it's an interesting thing to watch. If I were going into some part of this as a career, I'd be looking at energy storage because I think it's got the highest level of disruption and the greatest opportunity for massive change. We've got research efforts on everything from rapid battery replacement all the way through to different formulations for batteries and solid state batteries and supercapacitors and ultracapacitors remain some of the most interesting technologies that I follow.
Thank you, Professor Rao, for your excellent analysis. I believe all of the question actually you covered. Thank you for your explanation, Professor Paul. You are a climate change activist, and most important, you have a very strong views about green technology. Yes, in Asia Pacific, we are also trying to create awareness for the green technology. Even World Health Economic Forum, we collaborate with Climate Change Department of Malaysian government for public-private partnerships. We are also working. And what is your views and how we can develop better policy, sustainable policy for energy sector?
Yes, thank you, Sharif, and thank you everybody for your great comments. So I'll put in some my own thoughts on some of the things that all of the panelists have said thus far, and then add a couple things which may have been said by the first panelist, but I did, before I managed to come on to the call. So the first thing is, people are talking about their states and regional things. And of course, California, being such a huge chunk of the population, has done some very interesting things, has been very progressive in terms of, energy production and distribution and storage. Ontario, where I am, is relying significantly on nuclear. I think it's about half. And hydro, we have quite a bit of hydro, and wind and solar are coming up rapidly. So Ontario is the largest area population-wise that it's got a significant population, significant area, and Ontario got rid of coal many, many years ago. It was the first large area in the world to completely get off coal. So, I'll give it some kudos for that. In terms of, definitely there's big possibilities for improvement with the distribution of electrical power, whether it be going to high voltage, DC lines to transport renewable energy large distances, or, a few years ago, there was a lot of excitement with room temperature superconductors, but ceramics that are able to have basically zero loss and transmit electrical power. But there's been lots of issues with the material properties, like it's a very brittle. Ceramics are very hard but very brittle. And if how do you make a power line out of ceramics? It's going to sway in the wind and crack the ceramic and things. So there is still some research on that sort of thing, but that would, if something like that was, if there was a breakthrough in that area, then perhaps we could have much lower transmission losses. The grid, as has been pointed out, is very old and rickety and subject to failure in large parts of the U.S. It has not been modernized. The infrastructure money has not been put in, and it's causing a significant problem in places like in places where there's what we're seeing is, with climate change. I'll give an example of Colorado. Okay, so the long-term drought and record heat. And then we had the downslope winds in the winter, and there was very little moisture in the ground, very little snow, less snow in the mile high cities. Like I'm talking about the Denver and Boulder area, and the high winds knocked over power lines that were live, and that's triggered the fire, the recent catastrophic fire. That was the source of the ignition for those fires in multiple spots, and then the wind, of course, carried the embers from things that had burned, and that just raised whole neighborhoods and so on. The Paradise Fire in 2018 was also high winds, taking out knocking over live transmission lines, causing sparks, triggering the fires. So the power lines being knocked over. If we had a smart grid and ways to rapidly extinguish power and then they're starting to do that manually, more or less manually in some regions. If they know, the high winds in California, in particular, the Santa Ana winds are coming, they'll actually selectively take power off of lines to try to prevent, the triggering of fires. It's all a matter of energy density, of course. The higher the higher number of the higher number of watts that can be created per weight or per volume of material, is very crucial. And this is why we've been very spoiled with gasoline and oil and things like coal as well, because they have extremely high energy density compared to renewable powers. Of course, nuclear is a separate issue because a lot of the fears from nuclear rely on or over the concerns for safety of the actual power generation plants, but also the waste, but also proliferation of nuclear materials. But with the there are ways around some of these issues. I mean, one of the problems, there was never standardization in the nuclear industry. So every country, every power company designed their own systems, and it was exorbitantly expensive to make them safe. So, there are some interesting developments with small modular reactors, and if there can be standardization, they can get some good designs and proliferate them. That there can be a lot of, lowering of costs, because it's always a capital cost with nuclear. In fact, I don't know of any nuclear project that actually was constructed at cost. I mean, they're all, there's huge overruns with them. So the other thing is with the hydrogen. People often talk about hydrogen. I see it being pushed recently by the fossil fuel companies. Hydrogen is more like a battery. It's more like a way to get energy from one place to another place, because hydrogen, in the form of hydrogen, is very rare on our planet. Hydrogen is bound with molecules, hydrocarbons, etc. And hydrogen existing on its own is extremely rare. Generally, so you have to do things. You have to expend energy to create hydrogen. So, you're basically, it's better to think of it more as a battery sort of thing. And I guess one of the holy grails that humans have been talking about, engineers have been talking about for years, is things like fusion reactors, and it's worth following the field. I mean, China has some advances recently that were in the news, in terms of, people talk about a break-even point where, because there's a lot of energy to confine the deuterium and tritium, and then confine it enough for it to react and produce all of that energy from the fusion reactions. But so there's a break-even point, if you like, and China succeeded in in upping the amount of energy they could extract, as a rate relative to the amount of energy that went into the system. But again, it seems like it's always, that 20 years off or so. So, unless we get some sort of major, breakthrough, you can't really consider fusion reactors being part of the energy picture at any time in the near future. And also we also need to look at the consumption side, the demand side for energy, because we do a lot of things very inefficiently, and there's big improvements to reduce energy demand by improving efficiencies, but there's this paradox where, the cheaper we make energy, the more we use and the more we waste, right? So there's all of these different issues, as far as solar and wind in Texas, it's already been mentioned. I mean, that was just Texas, the choice of Texas to use systems that were not able to. I mean, it didn't get that cold, really. I mean, there's renewables run in many, many places that are much, much colder than it ever got in Texas. It was just that they did not expect such a cold outbreak of air. But of course, we know with the jet streams becoming wavier and the ridges going further north and the troughs going further south, that the idea of knowing of temperature with latitude is being thrown out. You can't always assume you go further north. Higher latitudes, the temperature is lower. Lower latitudes, the temperature is higher, when you can get these persistent outbreaks. And these outbreaks have been happening a lot quite recently, and causing, there's generally high winds where you get the transition between the cold and hot air. And we've seen a lot of problems with that that's occurring. So people so there was no reason really. I mean, the cost in Texas to have made renewables that would withstand that cold that they had are very, very low. They just went as cheap as possible. And also, when the whole power grid comes down, it doesn't matter. Like wind and solar was blamed a lot in Texas, and that's just by the people that don't like wind and solar. It's not the reality of the situation. Yes, and geothermal, yes, geothermal can be, it's a very good method in parts of the world where the geology is suitable. And, out in Canada, for example, in Alberta, the knowledge of how to drill holes and extract, for fracking or for the oil industry, that knowledge and technology and machinery is all there. And, for example, fracking, the holes in the ground, which were there for fracking, and once the gas peters out after a few years, they should be capped. Most of them haven't been capped, but those particular holes could be used for geothermal systems. The holes already there in the ground from the fossil fuel industry, you can put in geothermal systems. So that's one of the things, and you're using the same skills. So you could transfer people from the oil industry to the geothermal industry quite easily, in many places of the world, and generate vast amounts of energy from that. So those are just some of the ideas on what we can do. Thank you.
Thank you, Professor Paul. Mr. Jason, can you hear me? Mr. Jason? Yes. You are from Trans.
Can you hear me?
Yes. Yes. You are from Trans.
Well, I have tons I could say, but I got some pretty good questions there in the internal chat. If any of you guys want to grab one of those up, there's plenty to talk about right there. Where do you want to start?
So specifically, what's your view regarding this sustainable energy sources?
My view is that we have lots of technologies that we could be using that we're just not. I mean, there's a big difference between like Tesla and Edison. Tesla is pretty good at making stuff, but not so great at bringing it to market. Edison might be a maybe not so nice a guy, but he's important. We need it's important. You got to bring it to market, or else what's the point? And there is a lot of technologies out there that I think we could be bringing to market that we just aren't. I don't know why really, but there's John Searle and his SEG technology. That's a magnet motor, basically. Then there's a cavitation that heats water. I don't know for sure if this one works good enough to, I mean, it works, it heats water, but I don't know. I mean, somebody claimed over unity, and we know that's not true. But I mean, just how good does it work? I don't see anybody using it, so it must not work, but it works. There's a cylinder, right? And the outside of the cylinder has holes in it. Okay, and it spins and it causes cavitation. You put it in the one cylinder in between another cylinder, and you put water in there, and then you spin the inner one, and it'll cause a vacuum in the bottom of the cups, and pressure and temperature go together. So when them come together, it gets hot. It's the same mechanism from when you see a propeller going through the water and why propellers get eaten up. That bubble that you see like on the back of a submarine. That's cavitation. And there's like 3D printed magnet motors out there that, I don't know how much of it you can 3D print. Probably, I you can. It's a whole different 3D printer, but I also heard you can print magnets. Not only print magnets, but magnets now that have, like, if you got a north and south, it's like a pancake. You can have a whole pattern of what kind of pattern you want, north south on the magnet. And then so you could have like a magnet here on your cabinet and another one, and it'll attract and then stop. So now you got a, like, almost like a bearing that's no friction. So there's all kinds of stuff out there. There's still Tesla technologies that we haven't used. The apparatus for the utilization of radiant energy. This, it's cheap. People in hurting countries could, it's not that much of material. It's a ground and an oscillator, and you put a big metal panel up in the air to catch rays, and then you just have to have something that oscillates. If you have a capacitor that will slowly form a charge from the, and if you have something that will just discharge that capacitor, it's not that much money. It don't get that much energy, but it's like free. You know what I mean? And how many of them could you make? Lots. There's also like these little Peltier chips that if you put heat on one side, like if you put a candle under it, it'll make electricity, and it'll make stuff cold on top. So there's people making like rigged up coolers with these by, because if you run electricity back the other way, well, it's called a Peltier chip.
Peltier coolers.
Peltier, I think.
Right.
Yeah, so there's lots of cool stuff. I remember Rob said something about storage. Well, if you've ever seen an old church clock that has a wind up and there's big weights, and how it works is the weights become the potential energy, and as them weights slowly drop out, it moves some stuff, and then you got something spinning. Well, that same mechanism, only scaled up and in a deep pit. So, you could hang a weight down there, and now you got stored energy that you can, use. Something I've always wondered since I was a little kid is why we're not harnessing electricity. Yes, I know it's too much energy. We ain't got a wire that big, but you can make it do work, couldn't you? Couldn't you run it underneath something and heat something up and get something out of it? I don't, that's, now I'm rambling. Back to you, Sharif.
Thank you. This is really great discussions, and definitely it's a very good session for our audience, especially for academy, especially for the youth communities. I just want to share good news that yesterday World Talent Economy Forum, we collaborate with Harvard Business School because we are working with talent economy and Harvard Business Schools. They also believe that the talent economy is very important right now. So we are working with Professor Karin. Yes, she is executive director for Harvard Business School. So we will do more research on talent economy, sustainable human developments. Hopefully, we can bring more interesting sessions and opportunity for the audience of World Talent Economy Forum. Thank you, everyone. This is really, really excellent session. Especially, I am grateful to all of our speakers, those who continuously support World Talent Economy Forum. They join in our dialogues, and they add many interesting things, which will be really helpful for the developing world. I request all of our audience, please share our content with government, with academia, and with corporations. Friday, you know that we have our special episode. We arrange debate, so hopefully everybody will join in the debating sessions. Now, I directly want to go for the
What's the
concluding.
debate? What's the debate?
Yes, already we declared the sessions.
Does it say it already?
Yes, yes. So I directly want to go for the concluding remarks. Professor Donald, what's your concluding remarks for today?
Well, loved all the ideas, and I really want to support what Jason was saying. There are lots of different things. Wave energy we haven't talked about. You can actually look at the difference between saline and saline. And so when there's fresh water and salt water, you can use there's ways of using the difference between those to generate energy. There's, you can now, Edward mentioned this briefly, which is that you can drill wells deep enough that you can actually create what's called engineered geothermal. So there are many ways of producing electricity and storing electricity that we haven't exploited enough. I want to just mention the thing about the microgrid, and kind of, I think it's worthwhile to point out that in a sense, Texas could be considered a microgrid in that they have their own grid that's much smaller. It's not part of the United States grid. And look what happened. It's true that they didn't use wind turbines that would actually work in the weather. I mean, they have wind turbines in Norway. It's a lot colder in Norway than it is in Texas. Believe me, I've been there, both places. And so that's partially a problem of just simply not engineering it correctly. Simply, I mean, that's simple. You know, they just opened a nuclear reactor. It just started in Finland, which is one of the first nuclear reactor that they've built in at least 40 years. And in Finland actually has quite a bit of power because they have some major rivers, so they have great hydroelectric, and they have a very small number of people. But back to what I was saying, there are in Germany and other countries what's called low temperature superconductors for transmission lines. So they actually have transmission lines that do not lose any power, and they're expensive to cool down to the level that it allows for superconducting, but saving that 10% of electricity actually winds up paying for them, and they actually do, they turn out to be positive. They make more money than they cost. And the problem with that is, and I think that this is an important thing, in the United States and Europe and developed countries, people have a lot of their savings or their wealth in their homes. And what happens is the low temperature superconductor lines have to be on the ground. They're not wires, which is good because they don't get knocked over in high winds and cause sparks and start fires and all that kind of stuff. But to go from one place to another, they have to go on somebody's property. And when you put something like that on somebody's property, it potentially lowers the property value. So that means that every single solitary entity between two places where you're trying to put a low temperature superconductor transmission line is probably going to fight you and sue you and, you know, do everything they can for you not to be able to do it. In theory, you can buy them, but if you just think of the property values in Silicon Valley, running a very, very short superconductor line would cost a lot of money because the property is so expensive. So anyway, I just want to, so what I'm really saying is that I think a hub, that microgrids are a good idea, but they somehow have to be backed up by supplemental power if they can't produce enough electricity due to some sort of circumstances that are beyond their control. I looked at the power mix of the city of Palo Alto, and it's kind of interesting. I think I can get it easily here. I don't want to spend the time hunting for it, but it's one, yeah, here it is, I found it. The city of Palo Alto is 17% solar. They have their own power system, so they're a microgrid, but they're also backed up by the California grid. All of their carbon-based power, which is 21%, has offsets, which are cheating, really, because you're still making carbon, but it's offset by somebody who isn't making carbon. 39%, well, 40% is hydroelectric, 11% is biomass, 11% is wind, and 17% is solar. So only 21% of it now is carbon-based, which is something that's potentially possible everywhere, using all these different wonderful technologies. So anyway, I just want to say that as we start learning more and start building these out, as we're getting better and better materials, so there's actually possibility of doing high temperature superconductor at a relatively warm level, just the level of liquid nitrogen, which is liquid helium's darn cold, and it's pretty hard to make sure to deal with it. But liquid nitrogen, they use that in ice cream shops. I mean, it's around everywhere. And so if you're building it out or you're trying to do something new, I really recommend to think about the high temperature superconductors and all the various methods that are possible for generating and storing electricity. They're coming online, and arrange for them to be online because they're cost effective. They're in many cases they have no pollution, and they're something that I recommend everybody look into. And I'll pass the baton.
Thank you, Professor Donald. Professor David Smith, what's your concluding remarks for today?
Sharif, thank you for, like I said earlier, a very good topic. A couple quick points, though. I love what has been said, particularly from Rob helping put a framework in place on how power is generated, how it's put in place. Some of the discussion on storage, I'd like to make some comments in a minute or two. But also I'd like to talk about the Texas grid a minute. The challenge that Texas saw, as several people have talked about, was that we did not have turbines that were designed for extended periods of 0-degree weather, which just doesn't usually happen here. It's the same way why last summer, New York City and other places had power outages, because they were not designed to have power generation happen when the temperature was 90 degrees, which is at 90 degrees here in the summer, we go and get our sweaters out and put them on because it's so cold. So you optimize your power generation for the environment you're in. I mean, New York City should have had power generation that could have happened at 120 degrees like we do here, but they did not. So you've got to look at the economies of what you're doing in. It's not one size fits all. And while Texas does not pull power from the national grid, Texas is connected to the national grid. And last year we sent power to Oklahoma City and Oklahoma State and New Mexico when they had power outages. So we do contribute to that, just to kind of set the record straight there. But let's talk about the storage. Storage is a big issue. I had the privilege of leading for the United States Department of Defense, their high energy density storage roadmap. And we looked at all different types of energy storage. And yes, LI batteries and others have some challenges. And LI could not meet our energy density demands that were needed there. But a lot of the problem isn't just the materials, but it's what's called the allied technologies that go with it. So for example, when you look at battery storage, particularly around LI and the future types of LI, like LI sulfur, LI fluorine, Rod mentioned LI Air, LI Bicar, and others. It's not just the material, the electrolyte, but it's what is the separation technology? What are the cathode technologies? Really, how do you begin to look at how the next generation membranes have to come in place to do that? All of those areas are where significant scientific research needs to still be done if we're going to try to grow and enhance the whole chemical battery regime. But also, as you begin to look at it, there's others that we can begin to look at it and do. There is flywheel power, and flywheels are a very interesting way to store energy. There is, as we see in other places, there's quite a few ways to thermally store energy. There is a whole way of using salt and turning basically the large salt domes into an energy storage system. And there's just so many. We haven't really mentioned fuel cells. Fuel cells is a very interesting way to both store energy and generate energy as you go forward in the future. So it is really, when you look at this energy in this context, there's so many options. There's so many different elements in it. It also depends on your usage. How much energy density do you need? Well, that makes some very important determination. What type of energy do you need to have? Do you need precise energy? For example, when you build a semiconductor manufacturing plant, you've got to go ahead and even further condition the power that comes in from your utilities because of some of the requirements. As we begin to do more with robotics, as we do more with 3D printing, as we do some other things, the state of our energy as far as how precise is it is important. You cannot have wide frequency ranges. You can see when you have brownouts where the frequencies fall low, it will destroy electric motors and other things like that. So, the whole quality of the energy signals are very important going forward. And what this all tells me is there's a mix. There's a mix of ways we generate energy. There's a mix of ways we store energy. There's a mix of ways we transport energy. And a lot of it depends on geography. One of my favorite ways to look at generating power is where you have strong underwater currents. And it's just like the hydro we see off of a lake, off of a river generating, but we are taking advantage of ocean underwater currents too to generate power. At many places where temporary electricity is needed, where there's beaches, ocean beaches around, we use wave power to generate electricity. It's pretty green too. So there's a lot of places, and it really depends on what you're doing and how you're going to transmit it. Jason mentioned some of the Tesla effects. There's several companies around the world, including one here in Texas, up in North Texas, that is using Tesla generators, and they are distributing power at great distance. The one in North Texas distributed power down into the CARICOM region, the Caribbean region, after some of the last hurricanes there as temporary sources, and it was transmitted that distance in the Tesla wave and was received there in use. Now, Did I want to stand around that transmitter as it was transmitting it? Probably not. But still, we have those technologies, and they can be used for things like that. And it's all a cost of what the cost is, what the impacts are, what the local situation's like, what is the educational talent, the technical talent in place that can support them. I can tell you, with some of the scientific advisory boards I'm on, there's dozens and dozens of alternatives to lithium-ion batteries, but they all have issues, particularly when you look at the allied technologies, the things that go with them. So the goal is to really take a systems approach and understand that when we look at energy, the generation, the storage, and the utilization of it, it is a complex system in systems. And we need to optimize across all the elements for us to be successful in any given region and for any given application. So Sharif, thank you for letting me be part of this.
Thank you, Professor David Smith. Before I give chance to Professor Rob, there are two declarations. First, our debate. Already we declared that our debate topic is this House believes that climate change is the greatest threat facing humanity today. Our proposed, Professor Donalds and Mr. Jason, you can join with me as a debate analyst. Our proposed team, government, Prime Minister, Mr.
What if I want be on the other side of that one though? I don't.
Okay,
I don't
okay.
know if
You can give
this.
feedback.
There's
You
other
can
stuff.
yes, you can give. Yes, you can give feedback. Prime Minister Professor Rob, then Minister of the Parliament Professor Paul, then Member of the Parliament from the government side Mr. Marshall, from the opposition side Opposition Leader Professor David Smith, Opposition Deputy Leaders uh, Dr. Talib Rafael, and member of the opposition side, it's my propose, Professor Edward. So hopefully, and definitely Professor Donalds and Professor Jason, you will be analyst for the debate. I'm sure our audience really like our debate, and many of the peoples really enjoy. Already, I get a very good feedback that they want to see our debaters in the real parliaments. So hopefully, in the future, we will arrange some real debate in the parliament, maybe in Westminster Parliament or in any country's parliament. This is our objective. Beside that, we have another good news, because long time we are working with IEEE for collaborations, because we want to arrange a conference, Nikola Tesla Technology Conference. This December, we will arrange this conference, and IEEE actually accept World Talent Economy Forum. So hopefully it will be another interesting, and we are expecting more than 1,000 researchers. They will publish papers in our conference through IEEE Explore. So hopefully it will be another interesting project for World Talent Economy Forum. We want to invite you all, because we need a member for our scientific committees. Me and Professor Adrian actually working as a chair for this conference, but we need more people. So those who are interested from our board of advisory and from our speaker, they can join in our scientific team. So hopefully it will be very interesting sessions. Already many universities, especially research center, they are actually show their interest. They want to join in our conference. So these are the two declaration. Number one, debate. Number two, uh, the scientific conference, and number three, definitely we start working with Harvard University Business Club, business school. So hopefully we can publish more scientific research paper, as well as we can do more work with talent economy in the developing world. So Professor Rob, what's your concluding remarks?
Sure. So the issues surrounding green energy really have to do with how it's generated, how it's transported, and how it's stored. The problem we've got that we're dealing with is that petrochemical stayed predominant for an excessive period of time, and it dominated the entire ecosystem, making it very hard now to switch from petrochemical to alternative sources. Fortunately, over the last couple of decades, we've been making a lot of advancements. With regard to storage, one of the interesting areas, gravity-based storage has shown a lot of promise, everything from lifting a weight up when you have excess energy and then using the weights drop to generate that energy after time. Liquid sodium, where you heat the sodium when you have excess energy, and then you use that heat to generate when your generation source drops off. And the most interesting is now deep sea energy storage, where they use a bladder and fresh water under salt water, and they pump the fresh water into the bladder when you've got excess energy generation, and then use the pressure of the ocean to collapse that bladder and push the water back through what then becomes a hydroelectric generator when you need the power after the fact. With regard to transmission, an area to watch is New Zealand and Emerald. They're now doing a large-scale wireless transmission test for electricity. If it works and they can keep the energy losses down to something that's acceptable, we could solve a lot of the issues with regard to electrical energy transport, both in terms of aging infrastructure and what we've discovered over in California, which is the huge fire hazards associated with high wind and overhead energy transmission. And another energy storage area, at least at smaller scales, their solid state batteries are showing a tremendous amount of promise. And then, of course, with regard to generation, we kind of know how we can generate energy very sustainably. Geothermal, while it's expensive to put in, at least for now, at least it appears to be the safest. Arguably followed by solar, and then, as we mentioned, followed by nuclear. And then, as we mentioned, with solar and wind, you really require a storage infrastructure to go with it to handle your energy generation when you don't have sun and you don't have wind. And with regard to wind, one of the big problems with wind, two problems are brought up with wind generation. One is the recycling of wind generators. That was an early problem. We now can recycle carbon fiber at scale, and it's just a matter of converting those large blades, which are often made out of carbon fiber, into a formulation that can be recycled. And then the killing of birds, we've got alternative turbines that use different blade configurations. You can look them up, that don't kill the birds and are better at generating when the wind is less steady in a particular direction. So we are working through the problems with regard the safety problems to animals and with regard to recycling for solar. So these things are all being worked. If I were spending my time and energy, at least looking at an area or career area that I want to go into, it would probably be energy storage. That's where we seem to have the greatest need. And where we seem to be making the greatest advancement. The most interesting area, though, is energy transport, with wireless energy transport being the most interesting. Much of what we've talked about with regard to wireless energy, for instance, with regard to wireless energy charging your smartphones or even your cars, is like what's done with electricity. And that's inductive charging, and it doesn't cover much distance. And we really need a longer distance carrier to solve our bigger problems. But inductive charging works at close proximity. At least it eliminates the wires. It just doesn't solve our large-scale transport problems. So a lot of activity in this area and a lot of promise with regard to applied technology to make things better. We had a lot of discussion with regard to California versus Texas. Both states in the United States have had a huge problem with regard to long-term planning and moving from concept to concept without necessarily thinking through the implications, which is why California has had huge fire problems and why Texas has had huge reliability problems. And often the blame being focused on renewable energy has been misplaced and had more to do with the misplanning of the overall grid and less to do with the individual technologies that were on it. So recognizing that if you're going to do something large on a large scale that is going to be sustainable, you really need to think of the long-term implications of it and look at global climate change as something you need to design around, because it's with us whether we like it or not, and you can't ignore it, which means your generation capability has to work both in warm and cold weather, and so does transport and storage. And so thinking through the long-term, large-scale implications of your environment has a lot to do with your overall plan and implementation, and the fact you need to design for the world as it will exist in the 2040s, not the world that exists today, because by the time you get a large-scale change in place, a decade or two will have gone by, and that'll be the world that you're going to be living in.
Thank you, Professor Rob. Professor Paul, what's your concluding remarks?
Yes, lots of good points and food for thought in these discussions. With the gravity storage, maybe somebody mentioned it, but if the geography is suitable, when there's excess energy being generated, you can pump water up into a reservoir at higher elevation, and of course, just release that water to drive turbines. So, that's another very efficient energy storage mechanism. I think. I'm always amazed by the technologies that Tesla comes up with. I mean, you may knock Elon Musk, but Time recognized, his importance and nominated him as Person of the Year in their latest edition of their publication. I mean, you have to remember that, he almost, he led companies to completely revolutionize fields, and of course the electric cars, is the most, the company Tesla is the the biggest, the most important, I guess. At Tesla, there's a company, a small company, battery company that put their battery into a Tesla S model car, and I believe they achieved over 750 mile range between charging, which is quite phenomenal. So the technology is definitely going in the right direction there. What people don't realize so much is the of course there was a Solar City company which he's heavily involved in, and of course the SpaceX. And what's interesting is there's already lots of different technology crossovers from those companies. I mean, with the SpaceX, the idea of reusable rockets, people said it just couldn't happen. So, here's a guy, he comes along, he has a relatively small company, relatively much less money than defense contractors and the Lockheeds and the Martins and all of the military defense contractors. And he's completely revolutionized that industry with his successful launches. He's launched the constellation of satellites to bring the internet up into space. And so I just read Ashley Vance's book, which was written in 2015 called Elon Musk. And it's well worth, whether you like the man or not, it's well worth reading that, because he's basically revolutionized and taken on major entrenched industries and changed the way things are done, and had these tremendous breakthroughs. I think the SpaceX, one of the most important breakthroughs was a way to just improve welds using new welding technologies that allowed them to make these rockets out of more out of welded components, whereas before people were just the size was restricted by the desire to not minimize the number of welds in the rocket. And his technique basically rearranging the atoms in the weld to connect materials so that there's basically a seamless interface between two metals that are welded together. The metal, like when you think of the rocket, for example, turning a metal plate into the circular fairing of the rocket. So it's interesting when you think, if you really sort of study what he has done and figure out, okay, why is he being so successful? Why can't we get 10 or 20 or 50 Elon Musks, and we could solve many of these problems that we have? And what's important to remember with him is he's had this goal to make humans a multiplanetary species. because he thinks that we need to definitely do that in order to preserve human knowledge far into the future, because it's too risky for us all to be on one planet. So everything he does is directed to that, and I wouldn't be surprised if he succeeds with some of his goals of 2024 sort of time frame of getting people up to Mars. So how it pertains, so the energy densities of batteries and so on, I mean, all of the Tesla's been driving that. They've got their breakthroughs in battery technology, in all different aspects. I'd like to see him start working on some of the problems that maybe could address abrupt climate change. I'm thinking specifically of marine cloud brightening, which is an interesting technology idea, and mirror, which is deploying mirrors on the surface of the Earth to reflect some sunlight to cause cooling. But I really think that when you think about it, where's the best place you could install solar panels, for example, up in space in low Earth orbit, right? So nobody's going to be able to mess with it there. It's out of the way. It could also do a combination of absorbing sunlight and generating power, which could be beamed to Earth, but also to reducing the a tiny fraction of the sunlight hitting the Earth to cause this is solar radiation management, which would cause a little bit of cooling on the Earth to give us time to do all these other transitions, because the climate system is obviously going haywire, and it's doing that now. It's not in 2100, it's not in 2050, it's right now. And the costs of just think of the cost in terms of carbon, et cetera, for those massive fires which swept through Colorado, destroying thousand houses. If rebuilding all those houses, and the carbon that was in those houses going up into the atmosphere, and the smoke and all the rest of it. I mean, this is going to be a significantly increasing problem of fire, of flammable materials on the surface of the Earth as we get a warmer and warmer climate, a drier conditions in places. The look at the fires in California, for example. In the last few years, 2020 was sort of the burning in 2020 was double or more than double that of the previous largest fire year. And the smoke that's generated and affects people, air quality, et cetera, et cetera. And that's still only a small fraction of the forest coverage. So, I can see as we gain another half a degree or a degree in temperature, imagine losing almost all of the boreal forests. I mean, it'll be quite a different world, and this is sort of where we're heading. I think as bad as all the California fires and that, there's still a very small percentage of the acreage of forests. Right, so we're only scratching the surface of these disasters that we're seeing. Like, this is going to get a lot worse at an exponential rate, and I fully expect that we'll be into global food shortages within 5 to 10 years because of abrupt climate change disruption. So we don't really have a lot of time. So so I'm very hopeful that with the Musk deployment capability driving costs down to get things up into space, that we could deploy some things up there to help us deal with climate change down here. Thank you.
All right, I got to talk about Musk because he mentioned it. I like Elon Musk, but not necessarily really, I think, because the same way everybody else does. Remember earlier when I was talking about Tesla and Edison? Elon Musk, when you ask him, will say that he admires Edison more than Tesla, because he brings it to market, so that just kind of lets you know where his head's at. But anyway, this renewable energy is an awesome topic, and there are a lot of interesting motors and engine and ways of creating energy. I think we should, if you can have more of these, maybe we can discuss some of these in a little more detail and find out which would probably be the good ones, and which are the not. I mean, there's a lot of maybe put together what would be the best combination, because I mean, we probably figure there's going to be a combination, so. And we're running late, so nobody wants to hear me. See you guys. Back to you.
Thank you. Thank you. Thank you everyone for joining today's session. This is really great sessions. I believe our audience also like today's sessions. I request all of our audience, please share our content as much as possible. And thank you, our honorable speakers, Professor Donald, Professor David Smith, Professor Rob, Professor Paul, and Mr. Jason for your continuous support for World Talent Economy Forum, because you people are a strength for World Talent Economy Forum. Thank you. Bye-bye and take care.